Over the years, the Python community has produced a plethora of great tools for web crawling and web scraping. Data is valuable, so every company wants to obtain it and reap its benefits. Better price intelligence, improved lead generation, more leverage in the real estate industry, and so on. To gather data at scale, companies use web crawlers, special software that can do it automatically. Web crawling refers to finding, fetching, and storing web links. A typical scenario involves using software to automate it. These software instances are known as bots, crawlers, or spiders. People also use web crawling as a synonym for web scraping. But is it correct? Web crawling refers to the process of finding and logging URLs on the web. Google Search, for example, is powered by a myriad of web crawlers, which are constantly indexing URLs. Web scraping, on the other hand, is a more precise process. Its goal is to retrieve and extract structured web page data. The majority of companies working with data choose Python as their core technology. The most typical example is, of course, data science, although other tech industries utilize Python, which explains its surge in popularity over the last years. Python skeptics point out that Python is slower than other languages. In this case, the terms slow and fast refer to raw CPU performance, i.e., how fast a command written in a given programming language can be executed. In this regard, Python may indeed be slow. However, Python is blazingly fast in other aspects: business speed and time-to-market performance. Thanks to its code brevity, Python developers spend less time on meta work, meaning all the extra code the developer has to write to solve the given problem. These charts show us that Python saves the most valuable resource: developers' time. Python wouldn't become a bastion of productivity and development speed without the batteries included approach. It already has a rich and versatile standard library that is immediately available, without making the user download separate packages. Also, it is the combination of being free, open source, and cross-platform. This ensures that Python is accessible to the widest range of developers possible. Although not a library per se, Scrapy is still an important tool for web crawling. It's a full-fledged framework for web crawling and web scraping. This means that it can be used as a basis for custom web spiders when your project needs are more demanding. Although originally designed for web scraping, Scrapy can now handle retrieving data via APIs as well, which can be a more preferable way of acquiring website data. Using Scrapy can be even easier with Portia, a tool designed for visual scraping. This library is optimal when you need a custom solution for crawling and scraping HTML pages. Pyspider is another powerful web crawling system. One of its advantages is the optional web-based user interface, which can prove useful to people who prefer graphical interfaces over their command-line counterparts. Web scraping pros rarely have one active project. In most cases, they have to manage a dozen of them. Pyspider addresses this problem by implementing a dashboard, which allows the developer to edit scripts, monitor and manage their current crawlers, and view results. Pyspider boasts JavaScript support, meaning it's not restricted to pure HTML pages. Pyspider integrates well with Puppeteer, a powerful Node.js library for automation in Chromium-based browsers. Also, it supports both Python 2 and Python 3. MechanicalSoup owes its prowess to the technologies it was built upon. One such technology is the requests module that we discussed earlier, which is used to retrieve web pages. MechanicalSoup is also based on Beautiful Soup. MechanicalSoup developers highlight that this library would be a poor choice if the target website does not have HTML pages. The requests module should be used instead. The target website relies on JavaScript. In this case, Selenium would work better. This library is optimal when you need a rather simple crawling script without any JavaScript support, ticking boxes in a form, or logging into a website. Cola is similar to Scrapy in its approach. It's a crawling framework designed for crawling pages and extracting their data. However, this project hasn't been updated to Python 3. And with Python 3's dominance over Python 2, Cola may be somewhat cumbersome to use. Mechanize was upgraded to Python 3 in 2019. MechanicalSoup is a descendant of Mechanize, so they share a lot of functionality. However, MechanicalSoup is also lighter. It has 20 times fewer code lines than its ancestor. RoboBrowser, on the other hand, is MechanicalSoup's brother. Both libraries are built upon the requests plus Beautiful Soup combo. However, RoboBrowser hasn't been updated since 2015 and doesn't work correctly on Python 3.7. Lassie solves another specific problem: retrieving the website's general information via just one command. this data is returned in a well-formatted dictionary. Web crawlers may seem complicated, but yet definitely worth trying. Last but not least, you'll also need proxies. Without them, anti-scraping systems will detect that your web crawlers aren't genuine users, and they'll block them. Residential proxies address this problem by masking your web crawler, so the target server sees proxy users as real people from any country, state, and city they prefer. Naturally, this makes web crawling significantly easier. You're running a much lower risk of getting banned or encountering CAPTCHAs. Thanks for watching!